It begins with a storm that should have been routine, a cyclone forming quietly off the coast of the western Pacific. Satellite imagery shows a swirl, nothing more. A typical system, nothing alarming. Meteorologists track it with mild concern, updating their models as they always do. But deep beneath the storm's spiral lies something strange. The ocean surface temperature has risen by nearly 3 degrees Celsius in less than a week. A spike so sudden that even advanced models fail to account for it. A new warm pool has formed, thicker and more intense than anything in the region's recorded history. It stretches for hundreds of kilometers, storing energy equal to thousands of nuclear detonations. The first mistake is assuming the storm will behave like storms always have. Within hours, the cyclone undergoes explosive intensification. Wind speeds double. Pressure collapses. The storm grows so rapidly the outer bands outrun the models. By the time agencies update their forecasts, the cyclone has shifted categories twice and is still strengthening. A phenomenon meteorologists refer to in quiet voices, hyper-intensification, but this is only the trigger. As the storm grows, it begins to interact with the jet stream, a river of air thousands of kilometers long that influences weather across the entire northern hemisphere. Normally, these two systems ignore one another, but the upper atmosphere has become unstable. The jet stream, weakened by temperature imbalances, now loops downward, dipping far below its usual path. The cyclone connects with it like a spark hitting dry fuel. The jet stream twists violently, causing cold Arctic air to plunge south and tropical heat to surge north. Weather systems that should never meet collide head-on. New storms emerge where calm skies existed hours earlier. Rain bands multiply, thunderheads explode in the tropics, humidity rises. Wind patterns shift, and this is just the first chain reaction. Thousands of kilometers away, the Indian Ocean responds. Monsoon flows become erratic. A pressure dome builds near the Bay of Bengal. The entire region enters atmospheric instability. Scientists monitoring satellite data observe the same alarming pulse in sea surface temperatures, as though the Pacific and Indian Oceans are suddenly communicating through a shared imbalance. Heat migrates into the upper layers of the atmosphere, destabilizing wind shear. The monsoon collapses in places and grows violent in others. Rain falls in sheets thick enough to obscure entire towns. Lightning storms appear where none have been recorded in decades. Across Southeast Asia, humidity reaches unprecedented levels, pushing heat indexes past survivable thresholds. Cities issue emergency warnings, coastal villages evacuate. But authorities cannot predict what comes next, because no model has ever simulated conditions like these. In Japan, meteorologists observe pressure anomalies spreading across the sky like cracks forming in glass. The subtropical ridge weakens, pulling typhoons into new routes. One storm, originally projected to curve harmlessly out to sea, now hooks violently west. Another splits into two rotating systems, something seen only a handful of times in meteorological history. Atmospheric rivers, vast highways of moisture, begin drifting unpredictably, veering off their expected courses. One surges toward China with moisture levels equivalent to 20 Amazon rivers in the sky. Another plunges toward Taiwan, threatening flash floods and mudslides. Local governments activate emergency teams, but every projection changes faster than officials can respond. Meanwhile, in the South China Sea, the shifting jet stream awakens a dormant weather engine. A heat dome forms, a massive, unmoving bubble of hot air that traps heat beneath it. Temperatures spike by 8 degrees Celsius in under 48 hours. Thousands of kilometers of ocean begin steaming into the atmosphere, feeding storms across the entire region. This is the second chain reaction, and the world is now fully trapped in it. As the atmosphere destabilizes, air pressure shifts across Central Asia. A region normally dry and stable begins generating dust storms visible from space. These columns of sand and debris stretch thousands of meters into the air. Winds carry them across borders, reducing visibility to zero. But the real crisis forms in the Western Pacific. Scientists monitoring satellite data observe something terrifying, a convective supercluster forming, a massive fusion of thunderstorms that begins rotating, expanding, feeding on warm water and atmospheric instability. Within hours, it becomes the largest convective system ever recorded in the Pacific. Inside this monstrous storm, something begins forming. A low-pressure core, a tightening spiral. The seed of a mega-typhoon, it grows faster than any system has grown before. In less than 12 hours, it becomes the strongest cyclone of the decade. In 16 hours, the strongest of the century. And it is still strengthening. Authorities issue evacuation orders across multiple nations. But the storm is too large to flee from. Even countries thousands of kilometers apart prepare for the same system. And still, this is not the final crisis. As the mega-typhoon forms, its sheer scale begins altering sea levels. Ocean water is pushed inland along coastlines in the Philippines, Taiwan, Vietnam, and southern Japan. Storm surges reach levels once thought impossible. Even before landfall, flooding begins. The storm's massive size creates its own gravity-like effect, pulling surrounding weather systems into its orbit. Atmospheric rivers feed it. Temperature differentials accelerate it. The typhoon becomes a self-sustaining monster, feeding on the sky, the sea, and the earth itself. As it approaches land, meteorologists deliver the message they hoped never to say out loud. This storm does not fit any known category. Evacuation shelters overflow. Emergency agencies brace for impact. Coastal highways close. Bridges lock down. Military units deploy. Communication towers brace against incoming winds. And then the typhoon shifts unexpectedly, turning toward a region where evacuation has barely begun. The sky turns black. The pressure drops to levels that make people feel physically sick. Water crashes against coastal defenses with explosive force. Entire neighborhoods flood in under a minute. The typhoon shreds everything in its path, but even this is just one piece of a larger disaster. A chain reaction of atmospheric instability continues across the Pacific and beyond. Climate zones begin shifting. Temperate regions face tropical rains. Tropical regions face cold air bursts. Jet streams fragment and split. What was once an interconnected but stable system becomes a chaotic storm engine. And scientists watching this unfold issue one final warning. Our models cannot predict what happens next. As the mega-typhoon tears across the coastline, emergency crews struggle to comprehend the scale of destruction unfolding before them. Radar systems flicker. Weather balloons burst mid-air from violent turbulence. Ground stations lose signal. For the first time in meteorological memory, entire monitoring networks collapse simultaneously. The typhoon's eye, typically a calm, windless void, behaves differently. Instead of stabilizing, it pulses erratically, expanding and contracting like a living organism. Scientists observing satellite loops stare at their screens in disbelief. They have never seen anything like it. A storm core behaving as though it has multiple centers, each one fighting for dominance. Wind speeds spike unpredictably, surging from 250 kilometers per hour to over 330 kilometers per hour in less than 10 minutes. Trees don't just snap, they vaporize. Water doesn't simply rise, it erupts upward. The typhoon generates pressure so low that rivers reverse direction, pulled inland by the sudden atmospheric vacuum, and it grows louder. Survivors later describe a noise so powerful it drowned out human screams, sirens, thunder, and even the sound of collapsing buildings. The storm roars like a freight train made of wind and seawater, spiraling endlessly, grinding everything beneath it into fragments. But the true danger is not the typhoon itself. It is the chain reaction already spreading far beyond the horizon. Thank you for listening, and stay safe.